So hopefully it'll be above reproach and no one will falsely accuse him. Not to say that you have to be perfect, just hopefully you'll find yourself in that situation. We are in section 7.3, multivariable linear systems. Oh, and if you're just joining us, is anybody absent today? No, we're good. Except Izzy's in the wrong seat. But besides that, she bought a brownie. We'll be nice for right now. Tomorrow.
You bought your freedom.
Are you really blind?
Kind of. We'll say she bribed me, even though she didn't. It was for SpongeBob. I just care about their clip. I'm trying to help. We need to go ahead and cover section 7.3 for the homework due tomorrow. Homework 43 for all of us is due tomorrow. Okay.
Yes.
Post on Google Classroom. Just do the problems that are there. However, we did just grade section 7.2, but you guys said it was a pretty easy section, so hopefully I don't mess you up by not having the answer. I'll pull them up towards the end of class just so if someone did need the answers, they can access them still at the end of the video. Okay, I had you guys at the very beginning of class trying to set up why this section is important. Answer which one's better, and I hope by this point, if we have to solve this by hand, all of us are agreed to this one. You know the really cool thing?
What?
I did this the other day with Algebra 1 to give them a reason to learn completing the square. Because I gave them something like, what would you rather solve? Now, I'm making it up off the top of my head. Please don't judge me too much. I don't care. Judge me however much you want. But still, try to get the point of what I'm trying to say. X minus 5, quantity squared, equals, let's do something not nice, 6. That was on one side of their worksheet. Would they want to solve that, or, I think I was even mean, or, there was a 2x squared. I just need to remember what else it was. 37. Nope. 13. Minus 20x. Double checking, I think that's right. Nope.
Is that just a factored form?
12.
Oh, that's fine.
I'd rather solve the one on
The
the left.
left one. The left, not the left. What?
Minus 12.
The left one
The left
still.
one.
Just factor out a 2. And then you can do x method.
Okay, if you factor out a 2 and then move it to the other side, we're going to have a 6 and we're going to have a 10. So what are factors of 6 that add to be 10? None. So either remember your quadratic formula or, now remember these kids don't even know how to factor so great. Like, it's not their favorite. There was one kid that, like, admittedly when I asked said he chose this one because he likes factoring or he does it pretty well. So similar to you guys, he was like, whatever, just factor, throw it in the x method. He was thinking 24 and 20, I think. You guys pull everything out and you get a 6 and a 10. But your factoring is going to let you down, long story short. So if your factoring lets you down, okay, I can't solve it. Well, no, you guys know that there are other ways of solving besides just a nice little pretty x method if it works. So you could have gotten quadratic formula. But in their minds, factoring is terrifying. They usually get it wrong, especially if there's a number in front. Why did they choose this? Well, because we had just done 2 days, 3 days on solving with radicals. What can you do to both sides?
Square.
You can take a square root. If you take a square root of 6, I can do that in my calculator. They're actually doing decimals. Like, yeah, they're doing that. But then if you square root, okay, absolute value means there's a positive, there's a negative square root, plus or minus square root, and then add the 5. 5 plus or minus square root 6. They didn't even have to, and they don't know the quadratic formula yet. They all chose this one. Why does that give them a reason to learn this?
I don't know.
Completing the square always gets an equation to look like this. And you never have to do quadratic formula. Now, they're going to learn quadratic formula, and some of them, like you, will choose that, and like, whatever. I just memorize it and then forget it, and then hopefully my teacher reminds me and I remember it again and I use it.
That's me.
That's dangerous. However, they all chose this, and I'm like, okay, cool, let's start our section. Now, they didn't get to actually doing that until way later. They didn't even know. I just said, like, hey, if you like that side, you better learn this method. Okay, for you guys, if you like that side, and I do too, let's learn the method. Okay? So here we go. That's great for back substituting, that one not so much. This one you could kind of be like, ooh, I'll add the two together, and then now what? Row echelon form is the technical term for, now you guys need to highlight a couple of these things because you're going to be asked along the way, and even on the test, is this in row echelon form or reduced row echelon? Uh-oh, there's another one for it.
Oh my.
What you need to know is that there's a stair step with leading coefficients of 1. There are a couple weird exceptions in the sense of the stair step doesn't always have to be nice and even. Sometimes it is possible that this one like goes away and so then you jump 2 steps. But whatever your stair step is, if it's there, you need a leading coefficient of 1. And you do always need to at least get rid of 1 term, if not 2 for the next. Now, nice thing is your book has a much more technical definition that will cover all of those different cases. For right now, we'll just say, in general, it's a stair step, sometimes an uneven stair step. I know it's an upside down stair step, just work with me. Oh, the stair. The stair can be the blank space. There you go. There's the stair. Anyway, stair step, why? With a leading coefficient of 1. I'm going to get you guys going on the next page. Just kidding. Love it when the phone rings. On the video. Okay, you guys keep going in notes. And I'll get back to you. Hello? Oh, I'm sorry. This is a math classroom. No, that's okay. Bye. They're asking if Cookie was around. I'm like,
Cookie?
not here.
Cookie hers.
Okay, here we go. Steps to Gaussian elimination. Oh my goodness, there's so many new terms. Okay, so we have row echelon form. It's just a snazzy name for the stair step thing. Gaussian elimination. Gauss was an old philosopher, mathematician. Not totally sure off the top of my head why it's called Gaussian. Don't got that one for you. But he was a big deal.
What was he?
Elimination, oh my goodness, we just did elimination in section 7.3, I think, or 7.2. I think it's going to help. Legal row operations, wait a minute, we just wrote these with elimination, because I said, hey, it's legal to switch stuff up. It's legal to multiply a whole equation by something, and it's legal to add one whole equation to another, or even add the opposite, aka subtract one whole equation to another. So really, this is just saying we can apply elimination to harder problems. We can apply elimination to harder problems. Basically what's going on. Now please realize though, on this page, we're still talking about you as humans attacking a problem with the ability to be creative and choose different methods or choose different routes to your objective. A computer would be crunching into a system, whatever you gave it, like in a matrix, and doing certain ones of these operations like in a matrix, to solve what you want it to do, a set, systematic, going through the same steps every single time way. So I'm still with these, like interchanging 2 equations, the computer would never do that. It's like, whatever, give it to me, I'm just going to use it. I'm not scared of nasty numbers. You guys, on the other hand, are like, if I moved the third to be the first, my life would be easier. I'm letting you do that, even though technically we're trying to kind of learn a system that we could tell a computer, get it off cheese head, we could tell a computer to do for us. Just keep in the back of your mind, computers aren't scared of nasty numbers, you will be.
I fear no man.
You feel no pain?
No, I fear no man. I fear math.
I don't believe
My brother has a t-shirt.
Or it's a gift to let us know when we need to be
Yeah,
careful.
can you give it to me?
Those who can't feel pain have something called leprosy.
Leprosy?
No, I'm not kidding though.
That's what leprosy is?
Do you believe
I
that?
thought it was boils.
What?
I mean, that
What?
probably is a somewhat result of it, but no, it's a deadening of the nerves, and so you can't feel pain, and so then basically you just end up being like, oh, hey, I can do that, and you break your arm, and you don't know, and then all of a sudden, your arm starts getting gangrene and
Oh
falling off.
yeah, people like, I shouldn't be laughing, I'm sorry.
I know, but it is weird though, right? I read this story
So
once,
laugh
and it
at
was
that
like
because
in
you
third
said
world
one.
countries,
Oh,
leprosy
I'm
is.
laughing, that's, yeah. Wait, so like,
And
you
ability
fall
to
off
feel
a
dead
building and you
people.
don't die,
Very
you
true.
just don't feel anything?
If you
Yes.
don't die,
That's fine. Oh yeah, cause
You would feel the
fall
pressure.
off.
then you wouldn't have your nerves telling you that something's wrong. So you could put your hand on a stove and be like, yeah, it's fine. But then you look down and it's like, no, my hand's like falling off. I mean, not really, but you're gonna get the.
Well, wait,
It's like
is
very
it
big,
like
like,
something where
beer
it's
in
like
here.
people can't stand heat too, so it's like.
It's dangerous, yeah. Pain is actually a gift, which is there's a life lesson in that
Or
one.
except
It's
for the
super
people
hard and
you grow
super
from
hard.
pain.
What doesn't kill you makes you stronger.
That's a good song.
Ready for the system?
Yes.
This is how we do.
Wait, what was it? The chain thing?
Where's my crystal?
What doesn't kill you doesn't necessarily make you stronger. Depends on your reaction.
Well, what's the
Wait, what'd you miss? Ah, you should have been multitasking.
chain?
Okay.
And then there's
Okay,
like
chain
people
game.
like.
Chain game gets stair step.
So like get.
Now chain game, hold on, chain game, that means like chains have links. Links need to be put together in order to make a strong chain, right? Oh man, there's life lessons in that too. But chains, links, each link is necessary. There can't be like a breakdown in any of them, right? To have it be strong and usable. Or useful. So chain game, I just mean that there's going to be multiple links in this system, and we're getting towards like the computer program that helps us or works with matrices, thinking like a programmer in the sense of how could I tackle this in the exact same way every single time, even if the numbers change. We're not totally being computers today. We're not totally being computers, but we're getting close. I want you guys to go ahead and number each of these as a 1 and a 2 and a 3. Now right away, I know some of you are like, I could tackle this problem myself and I would do it my own way. I get that. I know that you're a creative human being and some of you have the ability to do that. However, if you were to make a mistake, I couldn't find it and neither could your group unless you did it the same way as everyone else. So even though you're like, well, I could in this one, no. We're going to go ahead and have the exact same system so that we can help each other find mistakes when they happen at their unique places. And kind of get prepared for a computer program would need to do the same thing every single time or else it's an ineffective program. Or have a way to do it every single time. Here's our first step. Our first step is basically, and this, you're humans, you're creative, I get it, so I'm not totally making you a computer yet. But our first step is to do elimination. Eliminate the x term with, okay, ready? 1 and 2, and then with 2 and 3. So our first step is to get rid of the x's. In what? Using 1 and 2 and 2 and 3. Now 1 and 2 is pretty easy in the sense of if we were to go ahead and just take these two off to the side, wouldn't it be really easy to do elimination, guys? My ones that like doing things their own way, you're not going to like me for the next few sections. My ones that are like, no, please give me a system because I don't want to have to think about it, you're going to love me. Well, not literally, but at least hopefully the math you're not totally okay. Negative 2y plus 3y is going to be y plus 3z equals 5. And preferably we want a 1y. Preferably a 1y. For the computer program, we would make it 1. For you guys, you're humans, I'll let you keep it whatever's there, but preferably a 1y. 2 and 3, we're going to do the exact same thing, but hold on. To do 2 and 3, don't we need to multiply 2 by 2 in this case?
And negative.
We're going to double
Well,
2.
it's not a negative.
We're going to double 2 and add it to 3. So then we're going to have, okay, we're going to have that 2x minus 5y plus 5z is equal to 17. That's true, but then we're going to have a negative 2x plus 6y equals negative 8. Do you see me multiplying this whole thing by 2 for that stuff?
Yeah.
Why did I do that? It accomplishes my goal of eliminating the x term, and I end up with 1y plus 5z is equal to 9. Once we eliminate the x term with 1 and 2 and 2 and 3, maybe having to do some elimination stuff along the way, now we're going to go ahead and eliminate the y term in 4 and 5. Whoa, whoa, whoa! 4 and 5, we only have 3. Oh,
That's 4 and 5.
didn't we make a 4 and make a 5? Nice.
Oh shoot.
In this case, I'm going to go ahead and make it with 4 minus 5, because if I subtract them, those y's are going to go away nice and easy. Now, depending, I might have to do a little bit of elimination work, but this one, if I just distribute a negative, I'm going to be just fine. Those y's are going to cancel. 3 minus 5 is a negative 2z. I end up with, that's my last step. You're going to always, if you follow the system, getting rid of x's in 1 and 2 and 2 and 3, you're always going to have just y's and z's. If you do elimination on the y's, you're always just going to get a z. So the last step is solve for z.
Just 2.
And then make the row echelon form. At that point, you're in the form that you want, and you'll be able to solve. What do you mean by solve for z? Well, can't we say z is equal to 2?
Yep.
Divide both by -2. You have just made your own form of this problem that's a lot nicer than that. You can say, wait a minute, well hold on, we need a stair step. So z equals 2, that's cool. What do we need next? Well, one of those ones with just y's and z's to be able to go back. Could you choose? Yeah, you could. Just has to be one of them. I'll choose the top one just because, why not? They both look about the same difficulty, and I'll just go for number 4. But you are humans, you are creative, you technically could take number 5 if you like him better. And then I'm going to typically just go for that very first equation for my top. If I was a computer or if I was a programmer, I would technically take whatever coefficient is in the x and divide everything by it. And I would probably do that for all 3 equations so that I know that my x's are 1 and my x's are 1, so I would know how to do elimination no matter what. I would probably divide by whatever that leading coefficient is, make them 1s if they're not already. And then I would know it's 1x and 1x, and I would be able to tell the computer, like, hey, no big deal, just subtract and it'll add down. And I could do the same thing for this one. I could just, they'd all be 1s, so I could do the same elimination. Then I could go ahead and divide everything by whatever coefficient is there, so I know my y's are 1s, and I can do this. Then I could divide, and I know my z, and I could just plug in, plug in, plug in. I'd make it what I want it to be. Hey, complete the square, making it what you want it to be. At this point, guys, if you haven't noticed yet, we're solving a 3-dimensional system, which means there's going to be an x, a y, and a z. My z is 2. If I plug in 2, back substitute, 6. 5 minus 6 is -1. So I get my z equals 2. By solving, I get my y equals -1. Then I go back one more time with both of those. You should show work, of course. But I get y plus 2 plus 6 plus 8, subtract. I believe it's a 1 there as well when we solve. And we have our 3-dimensional x, y, z as to where they intersect. Our x, y, z as to where they intersect. What is the system? The stuff in black. How to apply the system? The stuff in red. Now what's true about the system I just showed you? It'll technically always work as long as you are able to properly do elimination like section 7.2 homework. Now guys, there are pictures as to what you're exactly doing, but I'm going to actually leave that until tomorrow because the pictures, technically, I mean, they're good and all, but you're not necessarily having to draw a weird 3-dimensional, does it connect in the XYZ point like the one we just did? Is there no solution at all? Is there infinitely many but only in a place? But let me show you another example of one. Let's go to this one. Let's go to this one. I know we won't be able to finish the entire thing. But do you guys have a way of tackling this one? Just from what we just did?
Yes.
Because wouldn't we take number 1 and number 2 and try to do elimination off to the side, right? And when we did elimination, wouldn't we try to get these 2? Now, technically we'd have to subtract. And if you're really careful with mental math, maybe you would be okay. Subtract. Maybe you would be okay. But then we have to do the same thing with this one, equations 2 and 3. Ooh, that's a little bit messier because I'd have to multiply this guy by -3 all the way across, and then add, but -6 would cancel. -18 would be -10y. -16, what am I multiplying by? By 3? Sorry, -24. And then multiplying by 3, 9. -3. Double checking real fast. So I have my times -3, times -3, -18, times -3, -24, times -3, -9. And then we would go ahead and we would take our 4 and 5 and do elimination to them. I know they don't have leading coefficients of 1. But to do elimination, wouldn't we multiply this whole guy by maybe a 2? -2, because then my signs would be opposite. So I would have, and I'm going to come on down here, because then I could say, okay, that's going to be a 10y, and that's going to be a 10z, and that's going to be a 4. And I would end up with 4z equals 0. Wait, do you guys see though? The system will get you to your stair step every time. Once you have your stair step, just go plug in. The weird thing is how would all solutions or no solutions show up this time? Well, get into homework and check it out and see if any of them are weird. If they're not tonight, they will be tomorrow night. Follow the system, try to get the system down so that tomorrow we'll figure out what to do when the system doesn't quite work because it's a weird example. For those of you guys that are waiting around watching the video, trying to get the answers to last night's homework because I forgot to record, I'm pulling that up right now and we'll start recording as soon